Welcome dear students. In this video I'm going to tell you about the colloid, that is the part 3 of unit 5 surface chemistry. Okay, so let's start without wasting any time. What is colloids first? This is our first question. A colloid is a substance which is microscopically dispersed throughout another substance. A colloid is a substance which microscopically, very small, dispersed mean spread throughout another substance. So it is not a surface chemistry now, it is not adsorption, it is absorption. But adsorption will occur where now? Adsorption will occur throughout two substances. Suppose here green color molecules as dispersed inside the yellow color or orange color solution. Okay, so the word colloids come from Greek word that is kola, which means glue. Thus, colloidal particles are glue-like substance. Glue-like substance, you can understand glue, gum. We have Febistick, Febicool. Okay, these are the some glue-like substance which is come from kola word, Greek word, which means colloids now. Okay, so these particles pass through a filter paper, but not through a semi-permeable membrane. It can pass through a filter paper because filter paper have more larger pore than the semi-permeable membrane. Semi-permeable membrane is skin membrane. Okay, it cannot go through the skin. As you can see, if some ink we are going to pour through this filter paper, it can pass. It can spread all over the filter paper. But if that ink will fall on your screen, so it will not spread on your screen. Okay, so it is those particles which pass through the filter paper but not through the semi-permeable membrane. Hope so you understood. So colloids can be made settle by the process of centrifugation. Dear students, you have done these all things in 9th class. Centrifugation is a process in which we can separate, we can purify, we can separate the mixture of colloidal particle into solution. Okay, so there are two phases in colloidal particle that is very important to understand. Number one is a dispersed phase. Dispersed phase is a discontinuous phase. Second is dispersion phase. You can take it like a solute and solvent. Like solute is always dissolved inside the solvent, similarly dispersed phase is always mixed inside the dispersion medium. So here blue color is dispersed phase, you can say, and this water is dispersion medium. So dispersed phase particle have a diameter between approximately 1 nanometer to 100 nanometer. This is very important. In particular colloids, the dispersed phase, a solute particle or the material which is going to be dispersion, is between 1 nanometer to 100 nanometer. Such particles are normally invisible in an optical through their presence. We cannot see it with naked eyes. We need to use ultra microscope or for electron microscope to see those particles. So in junior classes we have studied. Now question is that from where colloid particle came and why we are studying it in surface chemistry. So we have studied in junior classes solution, colloidal mixture and suspension. Solution is those particles which cannot change its property, and the solute particle is very small in which light can easily pass. Colloidal solution mixture is having particle bigger than solution. It is heterogeneous media, heterogeneous mixture. Particle are intermediate in size, like bigger in size little bit. So light can disperse, I can say. Tyndall effect it is showing, Brownian movement it is showing. And suspension is what? It is made up of particle and a solvent. Its particle are largest than the solution and colloidal mixture where light cannot pass. You can say example of sand, water in this. Okay, here ink, water, and here salt, water. These are basically three types of mixture: solution, colloidal mixture and suspension. Hope so you understood. Now next is you can say here salty water is example of solution, milk is example of colloidal particle, floor suspended is example of suspension, and milk is example of emulsified colloids. Okay, so you can, dear student, you can make it by your own. It is my instruction to you. You all will make these three samples and you will explain solution, suspension, colloids in your own way by making these 3 samples and make a video, small video, and send it to me. Thank you. So comparison, if we will talk about comparison of solution, colloid and suspension, it is very simple. First we will compare it on the basis of particle size. So in solution less than 1, colloid 1 to 100, and suspension is more than 100. Appearance, it is clear, cloudy. Homogeneity, homogeneous, heterogeneous, and heterogeneous. Transparency, solution is transparent, colloids are opaque, awfully translucent, suspension are opaque. Separation, it doesn't separate, solution cannot separate, and colloids and suspension can be separated. Or filterability, if I'll say it passed through the filter paper, colloids also pass through the filter paper, but suspension are not able to pass the filter paper. So there are some example of colloids: milk, synthetic polymers like cherry blossom, you have polish, jam, jelly, fog, blood, or smoke. These are example of colloids particles. Now if we will talk classification, colloids are classified into 5 basic nature. First is on the basis of physical state of dispersed phase and dispersion medium. Physical state of dispersed phase and dispersion medium. Second is nature of interaction between dispersed phase and dispersion medium. Third is molecular size in the dispersion phase. Fourth is appearance of colloids, and fifth is electric charge of dispersion phase. Now pay attention, next 5 slides are going to be classification of these 5 type of colloids. First is based on physical state of dispersion medium. It is very simple, we have done it in solution chapter also, so I am not going to repeat it again and again. Here solvent was there, but we are taking in solution, it was written as solute solvent, but here in surface chemistry we are writing it in dispersion and dispersed phase. Okay, so dispersed phase is solid, dispersion phase is solid. So it is solid in solid, which is called solid sol. So alloy and cranberry glasses are example of solid colloids. Solid in liquid, sol, so ink and blood is the example. Solid in gas, aerosol, smoke and ice cloud is example. So liquid in solid is gel, so jelly is example. You liquid in liquid, emulsion, this is very important, emulsion, milk and cream is example. Liquid in gas, liquid aerosol, cloud, fog is example. Gas in solid, aerogel is example. Gas in liquid, foam, shaving cream is example. Gas in gas, all gases are miscible. Okay, so now question is coming how? Question will come like smoke is example of what type of colloids? So you will write it is example of aerosol in which solid is immersed inside the gas. So this is the simple question that can be asked in exam, so be ready. So next is based on nature of interaction. It means that bond between two colloidal dispersed phase and dispersion phase. So lyophilic colloids are lyophilic. Leo is liquid here. Leo mean liquid, and philic mean loving. So as we have done in 4th chapter of 10th class, hydrophobic and hydrophilic, hope so you still remember that thing. Hydro mean water, philic mean loving. So toward water, which bond is formed toward water, that is called water loving. Here which bond is forming between liquid, that is called liquophilic. Which bond is not formed, like oil and water, it not making bond, that is why it is called lyeophobic. Whereas water and ink or water and milk, it form bond easily, it's called lyophilic. So colloid solution in which the dispersed phase has a great affinity for the dispersion medium. Great affinity mean इसके साथ ये बहुत strongly bond करता है. They are also termed as intrinsic colloids because ये अंदर से bond बनाता है. Intrinsic mean inside. Such substance have tendency to pass into the colloid solution when brought in contact to contact with dispersion medium. If the dispersion medium is water, they are called hydrophilic or emulsoid. These term you need to clear for hydrophilic. The lyophilic colloids are generally self-stabilized, reversible in nature, and heavily hydrated. Example are starch, gelatin, rubber, protein. Example again, starch, gelatin, rubber, protein. These are some of the example of lyophilic colloids. It can come in multiple choice questions, so pay attention and see. These are some of the example of lyophilic. Now next is lyophobic. which is not going to be react, bond. Colloid solution in which dispersed phase has no affinity to the dispersion medium, it is called extrinsic colloids. Such substances have no tendency to pass into the colloid solution when brought in contact with dispersion medium. The leophobic colloids are relatively unstable. They are irreversible by nature and are stabilized by adding small amount of electrolytes. They are poor hydrated, and if the dispersion medium is water, the leophobic colloids are called leophobic or suspenoid. Examples are gold, silver, soles of metals, hydroxides, and sole of metal sulfides. Okay, so leophobic is external and leophilic is internal. That's why it is called intrinsic, and leophobic is called extrinsic. Hope so you understood two type of colloids. Sometime question is coming, difference between leophilic and leophobic, so you can write from here. Third type of classification is based on molecular size. If size we told, it means that it can be large, it can be small, it can be in group, it can be in single. So if multi-molecular is there, multi mean many. Okay, so this type of colloids are many in aggregation, in groups. So individual particle of the dispersion phase consists of aggregation of atoms or small molecules having diameter less than 10 raised power minus 7 centimeter. The particle are held by weak van der Waals force. Example, gold sol, sulfur sol. Example you need to keep. Macromolecule, macro mean big. So here the particles of dispersion phase are sufficiently large in size enough to be colloidal solution. These are called natural polymer. And third type of colloids are associated colloids. This is called micelle, that we have studied in 10th class. These colloids behave as normal electrolytes at lower concentration but behave as colloids at higher concentration. These associated colloids are also referred as micelles. जो झाग बनता है जब हम सोप का या वॉशिंग सोडा का पानी में मिक्स करते हैं. सोडियम स्टीरेट बिहेव एज इलेक्ट्रोलाइट इन डाइल्यूट solution but colloids in higher concentration. The soap molecule, higher alkyl sulfonates, polythene oxides, these are example of associated colloids. So there are three types of colloids if we will differentiate it on the basis of molecular size. These are multimolecular colloids, macromolecular colloids, and associated colloids. Okay, so next fourth is before going to move for fourth classification, how does soap work? It is cleansing action of soap, already we have done in 10th class. When a greasy dirt is mixed with the soapy water, the soap molecule arrange themselves into the tiny cluster, that is called micelles. Group बनाते हैं, associate हो जाते हैं. The water loving part, which is called hydrophilic, is of the soap molecule stick to the water side and point toward forming the outer surface of the micelle. Yeah, it is toward outer side. This is the direction, that is hydrophilic head, because water is here outside and dirt is here inside. And the oil loving or dirt loving hydrophobic, which can say against the hydro water, is trapped oil in the center where it can come into the contact with water and with the oil, then the dirt will safely removed from the shirt or some place of cloth. Fourth type of classification is on the basis of appearance. You know very how it is looking. Sols, gels. Sols are what? When colloid solution appear as a fluid, that is called sol. The sol are generally named as dispersion medium. When the dispersion medium is water, the sol is known as hydrosol or aquasol. When especially it is water, then it is hydrosol. Suppose we are mixing water in the paint. So paint is going to mix totally inside the water. That's why it is called aquasol or hydrosol. When a dispersion medium is alcohol or benzene, it is called alkosol or benzosol. Okay. So dear students, again I am telling these terms should be very very clear to you. You note down these all terms somewhere. Aquasol, hydrosol, alkosol, benzosol. Then last we have done micelle. Then up before that we did hydrophobic, hydrophilic, suspenoid, extrinsic colloid, intrinsic colloid. Then we did hydrophilic, emulsoid. Then term we have done. So all these terms you need to write somewhere so that it should be clear to you कि whatever we are doing that should be understandable or able to understand to you. So gels are second. So when a colloid solution appear as solid, see, when a colloidal solution appear like a fluid, like a paint, then it is called hydrosol, or it is called sol. Okay, when it is formed like a jelly solid, then it is called yes, gel. That's why word come from jelly. The rigidity of gel varies from substance to substance. For example, jelly, butter, cheese, curd, these are example of colloids which is from gels. Fifth type of classification is electrical charge dispersion. It is positive and negative colloids. Positive colloids are what? When dispersed phase in a colloidal solution carry a positive charge. Positively charged dispersed phase is called positive colloids. For example, metal hydroxide, alcohol hydroxide, methylene blue sol. Whereas negative colloids, very simple, it is then dispersed phase in colloid solution carry negatively charged. So you can focus here and here. Okay. So there are example silver sol, copper sol. These are example of positive and negative sol. So conclusion of this slides is this presentation was, what is catalysis that we did and its types, what is enzyme and its mechanism that we did, then we did colloids, what meaning of colloids, classification of colloids we did, physical state, on the basis of physical state, on the basis of nature, on the basis of molecular size, on the basis of area, on the basis of electric charge. Hope so you like this video and you understood everything. So try to note down, because this chapter is very simple. There is no numerical, no derivation, only theory part is there. So hope so you will now write down and you will perform good in your upcoming test. So thank you for listening me patiently. So next upcoming topic that we will going to study, that is separation of colloids, mechanical process, electrical dispersion, peptidization and condensation method, that we will do tomorrow's video. Okay, so till then, take care yourself, stay home, stay safe dear students, as this pandemic is going to be increased more and more and it is becoming more threatening to the common people. So take care yourself, stay home, stay safe. Thank you a lot.